today's lecture is actually going to be on types of sampling methods, but we need to start with how to randomize the sample. So the definition for randomizing is that this protects from outside influence and hopefully most biased scenarios. So if we can randomize, then we can protect from bias, and our sampling methods are going to use that. So another thing that we want to do is we want to make sure that the sample, on average, looks like the population. And what that means is really being just conscious of who you are asking or who you are talking to and who you are trying to get the population for. So an example would be if we're talking about a population of females over 50, let's say. Then our sample needs to be only females over 50. So you shouldn't be sampling 25-year-olds if your population is going to be females over 50. Another way that you could look at this would be if your population was New London and the people that live there, so New London people or peeps here, you want your sample to be not only New London residents, but ages 0 to 100 plus New London residents and all genders. So you need to be sure you're not just asking males, then we'd be talking about New London males as our population. So your sample needs to be a variety of people. So this is really what our lecture is on today. So types of sampling methods, they're going to use that randomization, all of those things that encompass that, knowing that your population should be related to your sample. But the first one that we use and the most common one is your simple random sample, or I'm going to refer to it as this. So this is the abbreviation that we will use. And this here is equal chances of being selected is what they claim here for these. So an example of using a simple random sample is having 80 students in a stats course, AP, US, the other AP classes. Okay, this is your population. Okay, we're going to sample 5 students. How would we use this? How to use SRS here is that we would need to select or put people from, we're going to number them. So this is our answer. Number students 0 to 79 or 1 to 80, and use a random number generator to get 5. And this is what, put this off to the side so it doesn't look like an S, to get 5. Sorry. And we're going to do this right here with your calculator, not today, but I'll show you in class how we're going to use our calculator to get this random number, this simple random sample through our calculator. So the important part here is we're numbering people and then we're using a random, some sort of generated algorithm to get that 5 that we need. Oh, and this is the exact thing that I was just saying. I didn't know I made a slide for it. So if you didn't catch it before, we were numbering them 1 through 80 or 0 through 79, random number generator to pick 5. And this would count for anything. So if there was 100, or you're talking about your grade, 124, you'd do 1 to 24, and then you'd select those people from there. The next one is your stratified sampling. So this breaks the population into groups of really similarity. I'll put similar interests, called strata. Okay, so the groups are called strata. And then use the simple random sample for each strata group to get a sample. So you're taking a large group, breaking them into smaller groups, and then using the simple random sample individually on each group. So an example of this that's very close to us is that the population is KRHS. Okay, my strata groups are going to be freshmen, sophomores, juniors, and then seniors. Okay, after that, I want to select, okay, for my sample, I'll do an SRS from each strata of 5 people. So my total in my sample would be 20 students out of KRHS. 5 would be freshmen, 5 would be sophomores, 5 would be juniors, 5 would be seniors, because I broke them up in that way. Another example that we can see is if you're trying to find out what freshmen at a college think of the food served on campus. Food Services believes that men and women typically have different opinions on food. How should you sample to allow for this difference between men and women to be determined? So my population is freshmen. My strata groups are men and women. So I've got 2 groups here, and then from there you want to take a sample of a simple random sample of men and a simple random sample of women. And depending on how much, some percentage based on the population here. And really this could become kind of a voluntary thing, which means that you could end up with some biased here because you've got some non-response and you're asking for a voluntary thing here. The major thing here is that by doing this, by identifying the population and creating these strata groups, I'm using stratified sampling. So even though we're using simple random sampling within this, since we broke them into groups before we did that, it's stratified sampling. And then the last one is cluster sampling. And this also breaks the population up, but this time it's kind of more random groups. into clusters, they call them. So breaks the population into clusters randomly, then use one cluster as sample. So this uses a simple random sample here to break up the population into certain groups, and then you're using one whole cluster, and this is the whole cluster. You're sampling everyone in that cluster as your sample. So an example would be the KRHS population. So KRHS is our population. And then our cluster groups would be simple random samples, we'll say into 4 groups. And these are going to be very diverse, all grades. And then our sample would just be one cluster. Okay, so that's how it differs from the stratified, is that the groups are random, not the sample. The sample is just one full group. See an example of that. So if we're still talking about freshmen and their food, we've tried the simple random sample and stratified methods, and both have caused difficulty in tracking people down to question them. Fortunately, freshmen live in 10 freshman dorms around campus. How could I use this to draw a cluster sample? How might that solve the problem? So in this case here, we could choose 1 to 2 dorms as a cluster group. That means that then your sample would become everyone in those dorms. And in this case here, you could go to those, so to actually sample, go to dorms and knock on doors. And that might get you more of a response than trying to send them out to everyone in the mail, or even try to hand them out to people, find out where they are for classes. A concern that you could have here is that, do we know the dorms are random? So is there an honors dorm? Or is there male-only dorm? Is there a sport-specific dorm? Is that going to, or any of these going to influence? Do any of these cause any bias to the question that I'm asking? So that could pose a problem. There's going to be ways that we're going to see bias in a lot of things. Now, the cluster sampling and the stratified sampling are sometimes hard to tell the differences between the two. So I do have a video for us to look at that shows kind of what this is talking about. So they're saying the population is all of these Skittles here. You can see the different bowls. So they're breaking them down by color right now. So this would be stratified sampling. So since we've got them in colors, you've got stratified sampling, they're in the special strata groups, and now they took a couple from each one. They did a simple random sample after that to get them down. So those are their strata groups. Okay, so that's it for that today.